Welcome to our discussion on variables and variable scoping. Generally, when you get into more advanced programs, you find the need to create and use variables. Maybe you're storing a calculated value to be used later, or storing constant text to be used in a qualification. We're going to study the behavior of variables so that they can be used effectively in our programs. We'll look at how variables are known in various processes and look at different scoping options to impact where a variable is known. There are three types of variables that are available to us. The first type is the reserved system variables. These are created for us. They typically begin with CUR. Some examples are curDate, curTime, curPage. A list of all of the reserved variables as well as the information that they will contain can be found in the Discern Explorer help file. These variables are known through the entire life of the program. They can be used in qualifications as well as for display. In this example, notice that the curDate and curTime3 reserved system variables are being used in a qualification. In this case, the qualification is being made on the p.updateDateTime field being between 30 days ago at a time of 0 or the start of the day and today right now. There are two types of user-defined variables that are available. The first are global program variables. They're known through the entire life of the program. By default, the value can be changed. Also, by default, these variables are going to be known in programs that the creating program calls. This behavior can be changed by defining the scope of the variable. We'll expand on scoping options in a future discussion. Global program variables can be used in qualifications and for display. In this example, a global variable was declared and called mailVar. It was defined as an F8 to match the data type of the value that is going to be placed in it. In that same declare command, it was also populated with a value using the constant declare option along with the UAR get code by routine. Constant makes sense since the value of our code values should not change while the program runs. Remember that the UAR get code by routine pulls the code values based on being provided the column, code set, and search text. This pulls the value from the global code cache rather than requiring a separate query being executed against the code value table. Later, that variable is used in a qualification to only qualify on mails. The second type of user-defined variable are the local report writer variables. These variables have a short life and are only known within the report writer sections of the select command. The value can be changed and used for comparisons as well as for display. These variables are not known after the foot report section of report writer or in any other programs. This example shows a local report writer variable being populated with the first 30 characters of the name full formatted field. The value of that variable is then displayed in column 10. The main difference between the local report writer variables and the global program variables is their lifespans. The global variables are known throughout the entire life of the program, while the local variables are only known in the report writer sections of the select command. Once processing has left the foot report section, the variable is no longer known. Let's dig into global variables further, since they'll provide the most versatility and function in our programs. When creating global variables, it is recommended that we use the declare command. This allows the assignment of the data type. Here's a list of the common data types. I1, I2, I4, and W8 are all integer data types. The smallest is I1, which is a 1-byte integer that can hold a value from -128 to +127. While the largest is a W8, which is an 8-byte integer that can hold plus or minus around 9 quintillion, that is 9 followed by 18 zeros. The H data type is a special integer data type that flexes based on the current system architecture. This was created for the transition from a 32-bit version of Millennium, that is, 2015 and older code, and a 64-bit version of Millennium, that is, 2018 and newer code. If a variable is declared as H in a 32-bit environment, then an I4 will be created when the program is run. That same program running in a 64-bit environment will create a W8. This allowed for creating programs in a 32-bit environment that would then make use of the larger integer data type when run in a 64-bit environment. The program will only be run in a 64-bit environment, then W8 can be used rather than H. F8 is a double precision float that allows for 16 digits of precision. This data type is used to store decimal values and for mathematical operations that may return a decimal value. There are two data types that can be used to store text: a character length string defined as C followed by an integer value that indicates how many characters will be stored, and VC, or the varchar data type, for storing variable length strings of text. If the string of text to be stored will be 40 characters or less, then the recommendation is to use the character length string. For strings of text larger than 40 characters that will not always have a fixed number of characters assigned to them, should use the VC data type. The VC data type uses additional memory to store pointer and location information that the character length strings do not. However, the savings from not having extra space allocated for a fixed length string for larger strings of text makes the VC data type more desirable for strings that are larger than 40 characters when considering memory usage. DQ8 is used to store date-time values. This data type is comparable to how date and time values are stored in the database for fields that end in DT under TM. DM12 is a 12-byte value for storing a timestamp, which allows for fractional seconds for a greater degree of precision than the DQ8 allows for. The declare command is optional. However, it is recommended to be used to define the data type. To create a global variable without using the declare command, you can use the set command before the variable name, followed by the value you want to place in the variable. Discern Explorer will then infer the data type based on the initial value placed in the variable. This can cause unexpected results when trying to place a larger value in that variable and having it truncated to that initial size. Let's take a look at an example that demonstrates this. We'll create a variable called greetVar and populate it with hi. Then we'll echo out the value of that variable. We have go at the end of each line so that when we click the include compile button, those two lines of code will be executed. We will then open the listing file by clicking on the listing button or pressing the combination of Ctrl-L at the same time. This will allow us to see the value echoed out. Excellent. We can see that hi was echoed out. Now, let's change the value of greet_var to another value, say, good morning. We will then echo out that value. On the second call echo, what do you think the value echoed out will be? Okay, let's see if that value was what you were expecting. We'll click Include Compile again, and then open the listing file. It looks like we only wrote out goo. This is the problem with letting the system infer a data type. It created greet_var as a C3 or a 3-character length string. It worked fine for the first value that we populated. However, if we try to place a string of text longer than 3 characters in length, then it will be truncated like we saw with good morning. That brings us to the question, how can we fix this so that we have enough space for all of good morning and whatever other greetings that we may populate this variable with? Excellent. We can declare greet_var to an appropriate data type that will hold the values that we plan on populating this variable with. If good morning is the longest greeting that we will use, then C13 will work when we declare this variable. Include compile, and then open the listing file. Excellent. We can see all of good morning now. The moral of the story here is that we should declare variables to an appropriate data type for the data we are going to populate them with, rather than letting the system infer a data type. Along with the base syntax of the declare command, there is also an optional with clause that can be used to define declare options. One or more declare option can be used. If multiple declare options are used, then separate them with a comma. Here are a number of examples showing the use of the various declare options. The first one, mvar, is declared as a C20, so a 20-character length string. A couple of declare options are being used here. No constant will allow us to pass in an initial value when we create this variable. No constant will allow the variable to be changed later in the program. In this example, it is the literal text of initial value. The public scoping option is also used. Scoping options are used to help control when variables are known or not known during certain processing. We will discuss shortly how scoping options can be used to control where a variable is known. The next example creates diff, declared as an I2 with a scope of private. The next example creates count_var as an F8. No constant is used, again, to place the initial value of 1.0 in this variable, which can be changed later in the program. The public scoping option is also used. The fourth example creates cvar as a C5 or a 5-character length string. This one uses the constant declare option to populate that variable with the text of hello. Since it uses constant, the value cannot be changed later in the program. It also uses the scoping option of protect. The last example creates a variable called stext as a C40. It uses the declare option of no constant to populate the text of short txt as the initial value. Since no constant was used, this value can be changed later in the program. Notice that some examples we used both declare options, while in others we used one or the other. The no constant and constant declare options allow for populating an initial value in the variable. The no constant is the default if neither declare option is used. This allows the variable to be changed at other points in the program. If one would want a variable to help them keep track of where to start as they process through batches, one may want to create a variable like startVar. This variable is defined as an I4 with the declare option of no constant, passing in an initial value of 1. After the first batch is done, this variable can be updated to help keep track of where the next batch needs to start. Constant sets the value initially and does not allow it to be changed elsewhere in the program. This is particularly helpful for variables that we do not want to change. An example of this was created when the add code value wizard was used to create a variable for the code value of male. In this example, the variable is named maleVar and was defined as an F8. UAR get code by was passed inside of the constant declare option to pull the code value for the value of male from code set 57, particularly looking at the CDF meaning column. Let's take a look at the other declare option that was mentioned. The scope declare option will allow us to control what processes can see the variables that we create. This is particularly useful as programs become more complex and interact with other processes or programs. For this discussion, parent processes and child processes will be used to help describe the scoping options. The parent process will be the process that calls the child process. For these examples, that parent process will be the main or parent program. There can be multiple child processes. They will be provided after we discuss the various scoping options. To assist with this discussion, a few of them that we will use are the select command, a subroutine, and a child program ran using the execute command. We will start off with the public scope. This is the default scoping option. If no scoping declare option is defined, then the variable will be in the public scope. This means the variable is known to all child processes. Let's say we have two programs, Program A and Program B. Program A will be the main or parent program. For the child processes in Program A, there is the select command, a subroutine, and this program is going to execute Program B. Variable pubvar will be declared as an F8 with a scope of public. So this means that it will be known in all child processes. It will be known in the select command, the subroutine, and in Program B. The next scoping declare option is private. With private scoping, the variable is not known to child processes. We'll create privvar with a private scope. Privvar is not known in the select command, the subroutine, or in Program B. This variable would be known outside of those sections in the main program of Program A. So that would be before the select command, between the select command and the subroutine, and so forth. The next scoping declare option is very useful when you have control of a child process, but no control and often no knowledge of what the parent process is doing and what variables that it is using. The protect scope allows a child process to create a variable with the same name as a variable in a parent process. The child variable is known to all subsequent children. When control returns to the parent, the child variable is no longer known and the parent variable is restored. With protect, you can create a variable in your child program with the same name as a variable in the parent program without concern of using the same name and possibly changing the value of a variable defined in the parent process. For example, we'll create prop_var variable in program A. For this variable, we will not assign a scope, so it will be in the public scope by default. Remember, that means this variable will be known to all of our child processes, like the select command, the subroutine, and program B. Let's say we want to create a variable in program B with the same name. Remember, the writer of program B may or may not know what program A contains. Program B can create its variable using the protect scope. Once that variable is declared, the prop_var from program A is put on the shelf temporarily while we have access to program B's version of prop_var. Once program B is done running and control returns back to program A, the program B versions of prop_var is destroyed and program A's prop_var is pulled off the shelf and brought back into scope. This allows program B to do whatever it needs to its version of prop_var without impacting the value in program A's prop_var. Let's move on to the next scoping declare option of private protect. This scoping declare option creates a very restrictive scope. Private protect allows a child process to create a variable with the same name as a variable in a parent process, much like the protect scope. The variable created with private protect is not known to any subsequent children, like the private scope. When control returns to the parent process, the variable created in the child process is no longer known and the parent variable is restored. This scope combines the private and the protect scoping options. This greatly limits what processes can see this variable. The last scope declare option is Persist Script. This scope allows a child process to declare a public variable and make it known to the parent programs. The variable remains in scope until the parent programs are complete. Programming best practices would recommend that variables be defined at the highest level possible. Persist Script allows us to work around how the other scoping declare options work by flipping the scope upside down. One reason that this may need to be done is if you have full control over your child process but cannot make any changes to the parent programs. Yet, you still need to make a variable that you created in your child process known to the parent programs. In our example, we'll create a variable called persist_var in program B with a scope of Persist Script. When program B is done running and control returns back to program A, persist_var will be known in program A. It should be noted that this scoping option goes to the highest parent program. Since most of Millennium is run through SCP servers, if the variable were to persist beyond the highest parent program, then the variable would live on even after all programs in that workflow have completed executing. Thus, the variable would persist until the server is cycled. This has the potential of negatively impacting any subsequent programs run on that server. Persist script goes to the highest script running rather than the highest process. There is a scope declare option that is not on this list that does go to the highest process rather than highest parent program. That scope declare option is persist. Persist should very rarely be used as it has the potential to have a negative impact on other programs that are run after it and can be difficult to track down the cause of that impact. The CPM script servers have a trace enabled that forces persist to act like persist script. It is very unlikely that you'll need to use persist, and depending on what server it is running your program, you may be blocked from using it. Persist script is the preferred method to allow a variable to persist to a parent script. A parent process is one that creates a child process. A parent process can have multiple child processes, but a child process only has one parent process. The child process is a sub-process to perform certain operations. This would include select commands, called programs, subroutines, inserts, updates, deletes, and merges. All of the scoping options are also available to other parts of the program, like subroutines and record structures. To help keep track of variables, consider using the set modify predeclare. This command can be used to identify variables that are set without previously being declared. This can prevent a typo in a set command from creating a new variable. This is applied at runtime. By default, it'll generate a warning message and allow the variable to be created and set. If the set trace deprecated is enabled on the server or the backend session, then an error will be generated and the variable will not be created or set. This command is a development tool only and should only be used in the development phase. The set modify predeclare would be issued before your program is run or at the top of your program. Then the set modify no predeclare is used to turn off the predeclare functionality. It is recommended that if you turn it on, that you also turn it off. The set modify no predeclare should be used after your program has run or at the bottom of your program. It is possible that some programs are written without declares, and leaving this functionality turned on could impact how they run.